All right, so now we're working with question 1981, question 1. And so again, we've got this 10 kilogram block being pushed along by this force and by a constant horizontal force as shown above. And the velocity of the block is 6 meters per second in the same direction as the force. And they give us the coefficient of friction, and so G equals 10 meters per second squared. So calculate the force F needed to keep the velocity constant. So again, if our velocity constant, A must equal 0 meters per second squared. So let's again, well, before we do anything, I think that we should do a free body diagram. So let's draw our dot over here on the side. And so we know that we have got the force of the surface, the normal force, our mg, and we see that this force is pointing to the right, so we're going to have that F to the right, and we also have friction going to the left because it opposes our motion, which is to the right. So we see that this force F is in the x direction, so we're going to find our sum of the forces in the x direction, which we know equals 0 because our velocity is constant, and the forces that we have acting in the x are going to be F and our friction. So to find this F by itself, we're going to have to add this friction to both sides. We end up seeing that F equals friction. And we know that our formula for friction is mu times normal. And so we're going to say F equals mu times normal. But again, we do not know this normal force. And we see that this normal force is pointing in the y direction. So we're going to find our sum of the forces in the y direction, which also equals 0 because we're not accelerating in the y direction. So we see n equals n minus mg. So let's add mg to both sides. And so you end up with n equaling mg, which you can just substitute up here. So then you end up with F equals mu times mg. And now we can plug in. So F equals 0.2 and our 10 kilogram block times 10, and we end up with 20 newtons. So now right here the force is changed to a larger force F and then that little apostrophe. So the block accelerates so that its kinetic energy increases by 60 joules while it slides a distance of 4 meters. So it wants us to calculate this force F. So this new force F, and this new force is going to be due to the acceleration. So let's do our sum of the forces equals this MA, which is going to equal, now looking still in the x direction. So again, this is going to be our free body diagram, but now we've also got this acceleration pointing to the right. So now we've got this acceleration pointing to the right. So it's going to be due to this F, this new F, minus the friction. And so again, we're trying to find this force F. So we add our friction to both sides, and we end up with this new F equaling MA plus friction. We already found our friction. Our friction is this mu times this normal force. And so we can just plug that in. And we also know, so it's mu times the normal force, and normal equals mg. And so we can say this friction, or this new force, equals MA plus mu mg. So now what we need to look at is, we don't know acceleration, so we're going to have to figure that out. Well, we currently do not know how to use this change in kinetic energy to find the velocity, so I just gave you guys the final velocity. So let's write down what we know. We know our initial velocity up here is that 6 meters per second. We know that our new velocity that I gave you guys is going to be that 9.5 meters per second. And we know that our change in x is going to be that 4 meters. And so the equation that we're going to want to use that incorporates all three of these, doesn't have time, it's going to be our v squared equals v naught squared plus 2a change in x. And we're looking for this acceleration. So you're going to subtract v naught squared by both sides. So you get v squared minus v naught squared equals 2a change in x. So you're going to divide both sides by 2 change in x. And so you get acceleration equals this v squared minus v naught squared all over 2 times change in x. And so now let's plug in. So our v final is this 9.5 squared, and our v initial is 6 squared, all over 2 times this 4. And so we end up with an acceleration equaling 6.8 meters per second squared. And so pretty much we're in luck right now, because down here the second part is calculate the acceleration of the block, and look at what we just did. So all of this right here is part C. A lot of times they're going to ask you to do stuff like that. So now, you guys, all we need to do is just plug in for this force. So our M, we know, is the 10, and then our acceleration is the 6.8, plus our frictional force, which is going to be our mu, which is 0.2, times 10 times 10. So we get this new force to equal, let's see here, it's going to equal 68 plus this 20, and so you're going to equal, it's going to end up equaling 88 newtons. And that is your final answer.